Hey, there we are. Good morning, good afternoon, good evening, whatever time it might be where you are. Welcome back to the live stream. My name is Jeff Fritz. Today is August 6th, 2019. And we're going to write a little bit of code today. How's it going there, chat room? Good afternoon, good evening. Great to see folks. Look who's here. Paolo is here. Welcome. Portal 7 from Argentina. Thanks so much for joining us today. That's great. Maria 00. Hello. Stelzy, good to see you. Code Stencil and Musical Bookworm. Code Stencil connecting from Canada. That's awesome. Always great to hear from my neighbors to the north. Thank you for tuning in. I wanted to do something a little bit different today. We've been working on doing a little bit of, we're doing that forms over data type of thing. We've been going through and we're doing a little bit of yak shaving at this point. Just trying to connect the dots. I wanted to get a little bit outside that. Take a stream or two here and let's go just a little bit outside our comfort zone. Let's try something new. And I want to try ML.NET. I've heard a lot of folks from Microsoft talking about ML.NET and how important machine learning is. And you hear this from other folks in tech also. How important machine learning is. Paolo, good evening from Portugal. Well, good evening to you. Thanks so much for tuning in. And I want to learn a little bit about this. And we've done some work around our chatbot, so it does all kinds of neat customized things. You can execute the help command there in chat, and it will interact with you, right? It'll answer some questions based on what's in our FAQ. It'll, to the best of its capabilities, do some analytics and try and match up and get you a good answer for things. Well, I'm always wearing a different hat, and I'm wearing my Visual Studio 2019 hat tonight because I want to get in and look at this feature that comes with .NET now and learn a little bit about it. And I think we might be able to learn how to use ML.NET, extend it a little bit, teach it what some of my hats are, and maybe then we can have a hat command in chat that will recognize what hat I'm wearing on that stream and tell you what's significant about that, right? This is the Visual Studio 2019 hat. I wore this for the Visual Studio 2019 launch on April 2nd, 2019. Done, right? We can load that data about the little blurb, the little, story about why that hat is important. We can put that into a database somewhere, maybe even a CSV, just so it's sitting out there on disk, real easy to load. But identifying which hat it is, that we can do a little machine learning and have it just look at the image and maybe identify what it is based on the color and the pattern. If we can recognize it, we should be able to work on that. Hello there, Kevin. Good to see you. I'm doing well. Thanks so much for joining us. So let's head over to the code and we'll get our music set up here. Hey, there we go. Thanks so much for tuning in. See over here, this is the new camera, right? I still have problems with the color coming off the Razer Kiyo. It doesn't quite color right, and I got to deal with that a little bit more. See what we can do. It's good to see you, Dee Dee. Thanks so much for joining us. So let me get some music running in the background here. I'm going to share, this is the Getting Started tutorial for ML.NET. And we're going to walk through this. It should take about 10 minutes, it says, and maybe we'll learn enough here that we can start to extrapolate and go after building a model, training that model, and maybe even getting it into our stream tools, into our chat bot by the end of the session. If not, maybe we'll get to it tomorrow. And I have a guest coming up later this week. Let me get some music playing, and we'll come back and talk about the guest. And we might have an announcement along the way here as well. Another announcement along the way. Let's see here. Let me go over to my music to code by Bank. You know what? Let's play Indigo tonight. Here it comes. This is music to code by. It's written by our friend, Mr. Carl Franklin. It's designed to get you in the groove, to get you in the flow, so that whatever task it is that you're working on, you can focus on, you can get stuff done faster because all your other worries will kind of fade away because the music is just groovy and it gets you into that sense of flow. Check it out, mtcb.pwop.com. You can execute the music command there in chat. Do me a favor, drop our friend Carl Franklin a message on Twitter. He's at Carl Franklin. Let him know how much you enjoy the music We want to thank him for letting us listen to his music while we write some code here together live on stream. All right. So this is the sample. This is the ML.NET tutorial. I want to walk through this a little bit so we understand what this is delivering, what this gives us, and we'll see how we can use that to apply to our bot and to this scenario where we want to train it on some images to identify some hats. You know what I mean? What do you think, chat room? Does that sound like a good, interesting experiment we go through here tonight? Good to see you, Blazor, Mr. Magoo. SQL Mr. Magoo is stuck in relational database land, but Blazor, Mr. Magoo, is here with us. So good to see you. So, two things. We are at... Where'd my stream elements... Where'd this thing go? We lost our gauge here. No! Right? Mr. Couture, right? You know what I'm saying? The little gauge below me here is gone. Oh no, I gotta go fix that real quick. I want to put that back up there because we are at 7199 followers. That is tremendous. I am so thrilled to see that. Let me turn back on the gauge here. I don't know why it's turned off, but we will turn that back on. Follower goal. There it is. And see, the follower goal even has the wrong number on it right now. It is 7199. Save changes. Save changes. And boom, there it is. 7199. For each multiple of 100, as we approach the magic 8,000 number, I'm going to give away a set of stickers randomly to somebody who's in the chat room. We are one follower away. So if you're out there, if you're a friend, you enjoy what you're seeing here on stream, if you like writing code, you want to learn something, and you want to be notified next time I go live, click that follow button, click that heart just above my head there if you're on the Twitch website. If you're in the app, it's somewhere up there. You have to click on the video and it'll appear. Click that heart. It's completely free to sign up and follow, and it'll help us get one more follower closer to that 8,000. Wait a sec. Dee Dee was already following us, wasn't she? I think she's playing a game here. Portal. That is music to code by from Carl Franklin. See that? There we go. Now we got our... I think that's the 7,200th follower. Zalvixiadin? Did I pronounce that right? Let me make sure that I see this flip over to 7,200 because this doesn't count unfollows below me. It doesn't resolve that. I see 7199 still sitting over here. Accidentally unfollowed, says Dee Dee. Accidentally. Sure. It was just an accident. I don't. Yeah, the number on Twitch hasn't updated. I think you, both of you, unfollowed and followed. There, isn't that what you did, huh? We're close. We're very, very close. Hey, Eldorian, good to see you. So, yeah, that's the music to code by. You can, well, you can go to the website and then download copies if you want to listen to it on your own. But I found a bunch of stickers here, not just our emote stickers that will be thrown in the sticker pack this time. And I'll send these anywhere in the world. I've got, of course, the .NET bot. There he is. I've got Super CSharp. There it is. And we're going to make those, we're going to put those back in the emote rotation here so that folks get to use those. I've got the rainbow bearded Octocat. I've got the shaded Fritzbot, right? He's so cool. And I've also got the rainbow bearded paperclip. I know! Well, I don't think Scott's here. I think it's just us. Good to see you, Janescu. HR Book, good to see you. Can I send that to Denmark? Absolutely, I can. That is not a problem. I am more than happy to send stickers to Denmark. We sent some stickers last time to the UK, and I sent some stickers even to Russia. So, I'm not sure if they made it to Russia yet, but I sent them. We'll see if they... And I've also got some NuGet stickers. Look at those. Ho-ho! There's a throwback NuGet stickers. So, throw them all into a bag and get them out there into a bag, into an envelope, and send them out. So, but we're going to talk about ML.NET here for a little bit. We'll see if we get some new friends joining us. Click that follow button, and I'm going to reset that number because that number's not right, and I don't want anybody confused. Try to see my PC. I can't see your PC, HR Book. What should I see on your PC? Let's see here. This should be, see, stream elements, it isn't a real number that they're looking at here. There we go. They more or less draw a line and they say who follows. They don't measure when people unfollow and correct it at all. So we're going to take a look at ML.NET here and see what we can learn about this, and hopefully we'll learn enough so that we'll be able to train a model to recognize images. Now, I've seen some other folks that have used similar technologies, similar machine learning technologies, to train models to do all kinds of things to help train around image recognition for people's eyes. And there was even someone during an event, they were using it to train to learn about makeup that women were wearing and be able to recognize the colors that were on women's face. Impressive, very impressive use of the technology, that kind of image recognition. And I think if we can do it at something as simple as, what's on my hat? What's that on my noggin? What do you have there? Gaiazo with, oh my gosh, all kinds of stickers on your laptop there. I'm looking. I don't see any stickers I recognize, but we can definitely, oh yeah, we would, a rainbow bearded paperclip and some of the other ones that I have here would look kind of good on there, right? There's what HR Book's laptop looks like. That's a lot of stickers. That's a lot. So, all right, let's see if we can go through this. I know Weezboss, or Westboss. No, I don't. So let's take a look. First thing it wants us to do is it wants us to install the ML.NET Model Builder extension, and it's currently in preview. All right, so I'm going to click over here. The ML.NET Model Builder. You know what? I already have Visual Studio open, so let's go to extensions over here. Let's see if we can find it this side a little bit easier. So I'm going to go to online, and let's see if we can find ML.NET Model Builder. There it is. So I want to download that. Downloading. Thank you. All right. Need to restart Visual Studio, so it applies. I don't. He sales sticker. Who? Let's see. So, Model Builder is a simple UI tool for developers to build, train, and ship custom machine learning models in their applications.
CodeMonk_Dave just subscribed.
Whoa, Dave! Thank you so much for that subscription. Look at the emote fountain here. Thank you so much for that. And we'll make a donation to Coder Dojo. Thank you very, very much for that. We're making donations all quarter long for all of our cheers, all of our subscriptions to Coder Dojo, who are helping to build facilities, train trainers, and give folks all around the world an opportunity to learn and grow their careers in tech. Thanks so much. I really appreciate the sub. And brought your Twitch Prime, too. If you have an Amazon Prime account, you can link that to your Twitch account, and you'll get one sub free anywhere on Twitch. If you use it here, I'll make that donation, and you'll get all the cool emotes. We have 19 emotes. You get 17 by default. If you want to subscribe at a higher level, that's okay. We'll give you some extra emotes for that. Do all these stickers add enough steadiness to the laptop for it to survive falling from 2 meters? Let's see here. So we're going to use the model builder to build, train, and ship custom machine learning models. Well, if we're going to teach some code about my hats, we're going to need some custom models, because I can guarantee nobody knows what my hats are. Know what I mean there? I mean, you know. All right, so this is, yep, go ahead and modify Visual Studio. Do the thing. Load the stuff. Yeah, go ahead. Shut down all those other processes. Do it. Do it. Come on now. Where'd my music go? It just stopped. Are you kidding? What the heck? Are we still here? Okay. Visual Studio Installer literally just took down the entire stream. That was to kill a process. Are you kidding? That's not gonna work. Know what I mean? Let's see if it... I don't think it installed that extension. No, it's not here. Right, model builder, download. Right, it's gonna go through this thing. Carrie Payette.
Boo.
Thanks so much for tuning in, and I appreciate that cheer. Do I need to restart it? Is it going to do the thing? There we go. I need a notepad. Thanks so much, Carrie, for that cheer. We'll log that with the rest of our code as we go through it here. And we'll make a donation to Coder Dojo. Thanks so much. Yeah, what the heck is this thing doing?
Wait, Master. It might be dangerous.
I'm going to click that end task button and see if it crashes me again. I'm clicking, nothing's happening. Oh, here we go, I'm dying. Visual Studio closing should not crash the machine. This is insane. This is somebody's... Look at this. What the heck is it doing? Holy crow. Like... when this settles down, my CPU is usually in great shape. My memory's pegged right now because I've got so much Firefox open. But let's... I'm not using that right now. Like, you're kidding me, right? Let's try and do it this way. I mean, what else is it trying to close? I'm not sure what that is. Right, there's Karnak running. There's Discord. I mean, .NET isn't running in the background here anywhere. I'm not quite sure what those are. Okay, Skype. I can kill Skype because we're not on Skype right now. But still, I'm like... Thank you, Blazer Mr. Magoo. like... Okay. I want to put it just in the preview version. Brother, here we go again. There are no open instances of Visual Studio. It's not running. It's not there. It's not up here. So why does it think there's... Yeah, there's Cortana processes working, absolutely. But why does it think that there's Visual Studio running? You know? Good evening, Fixter Jake. Great to see you. Yeah, reboot my foot. There we go, finally. Oh, thank you. You even put it right on Twitter. Let's see. You would say kill everything related to Visual Studio, download the V6 instead of download on Visual Studio. It should be the same. We should be going through the same thing. Is that Key or X? Time to reboot? Nah, we're fine. HR Book bought some stickers from West Boss and I've bought from other places from Denmark, anywhere else in the US and UK. I usually go to Sticker Mule is where I get stickers, and I'll get them from there. All right, so that looks like it says it installed. Continue. Create your app. Open Visual Studio. Create a new .NET Core console app. I'd be happy to. Let's do that. There comes Visual Studio. Scoot this over to that side, and I'll be running over here. Now, I'm running at 1920 by 1080. Feedback about the docs. I want to be able to put this side by side with the project I'm working on. Be great if I could have this collapse up, right? Let's call this first MLNET. And I never put stuff there. I don't know why it never remembers that I always put stuff in CDev. So, why preview? Asks Lies Live. Good to see you. I always use the preview version of Visual Studio because I want to show the latest and coolest things that are available that we can work with. So, all right. Oh, Threnan with the PHP badge. What is that? No, kidding. At least I didn't break out the horses. Chris Jones.
Chris Jones just resubscribed for 12 months.
12 months. Welcome to a year. Thank you so much, Chris, for a year's worth of subscribing. I really appreciate that. We're going to make a donation to Coder Dojo, and we're gonna put you in a new badge, a new loyalty badge. You're gonna get the hat, the rainbow hat with the propeller badge. Fantastic. Thanks so much for your support, Chris. Let's see. Lies Live asks, do I work on that team? Yes, I do. As a matter of fact, yes, I do. All right, so I have a console app with .NET Core. We've opened over here. Change the project name to MyMLApp. This one works. Add machine learning. Right-click on the project in Solution Explorer. So let me go back to Solution Explorer. I don't need Live Share right now. Go away. I can get rid of some of these other ones. I'll get rid of Server Explorer because I can. SQL Server, Object Explorer. Yep, you can go away too. I'm not using that right now. Solution Explorer. All right. Right-click and say Add Machine Learning. There it is. Well, that's easy. Okay. This opens the ML.NET Model Builder in a new docked tool window inside Visual Studio. Model Builder will guide you through the process of building a machine learning model in the following steps. Okay, let's see what we got here.
Make it so.
I'm working on it, Picard, okay? Okay. You have to work a bit more with Stripe, C#, and JavaScript, says HR Book. You just write me if you think you want to send a sticker to Denmark. Well, I'll raffle one off when we get one more follower. I will raffle off. I've got, a handful, like 6 different ones. Let's see. I should live share the Lies Live. Make sure enable console, run as admin.
What'd you do?
Do you really think I'm gonna fall for that? Do you really think? Oh my goodness, Michael Jolly, 15 Raiders from Michael Jolly stream. Thanks so much for joining us. It is very cool to see you. Welcome on in, Raiders. My name is Jeff Fritz, and we're writing a little bit of code. I write code here on Twitch, and we're learning all about ML.NET, machine learning with .NET. And we're using the new model builder and ML.NET framework that's available with .NET Core. It runs on Windows, Mac, and Linux. And we're walking through the tutorial right now. Let me see if I can click that link. Let's share that link back to the chat room. You know what? I think I have it on the stack there. There it is. There's a link to the tutorial if you're interested in picking it up and following along. What were you working on today, Michael? Great to see you. Retro CRT is here. Electric Havoc. Great to see. Thanks so much for joining us. Carrie, thanks so much for dropping that shout out there. Settings, projects and solutions, locations. See, I thought I had that set. Come here, you. Settings. No. Options, and that's data lake. Why am I going into data lake? Thank you for the follow. Is that Valdenai? I appreciate the follow. Let me make sure that ticks over. It says 7,200 here. There we go. That's 7,200. Let me follow this one set of instructions here. Where was it? 1 second. Projects and solutions. Projects and solutions. See, I don't... Oh, there it is. Right? And locations. Projects locations. Are you kidding? That'll make my life a ton easier. Michael Jolly was working on a custom credit roll that displays everyone who subbed, followed, cheered, or contributed, playing sounds, etc. with their name and profile image. That's pretty cool. That is really cool. Make sure you check out Michael Jolly. He's doing some really cool stuff over there, making Twitch better. Thanks so much for the raid. Here we go. ML.NET is cool. You have some history behind that. All right. We'll discuss that in a bit, but we hit our 7,200 followers. At every 100 followers, as we approach 8,000, I'm going to give away a pack of stickers. And I ran through the list of them here. I've got stickers based on all the emotes that we have here, and I've even got the NuGet logo I can give out as a sticker. So I've got the Lash tools here. Look at that. I'm going to clear the list. Drop something into chat. I don't care what you write. Words, something PG, something friendly. Drop into chat, and it'll put you into the collection here, the participants list, so that you could win a sticker pack. I'll mail it out to you. I'll mail these anywhere in the world. Yes, even Denmark. No, I'm not mailing out Snickers. Snickers? Snickers is a candy bar that Fritz can't mail out. Sorry. The more you know. Yes, stickers. Code stencil. Something works. Absolutely. Smedward. Good to see you. Denmark. Yes, Lies Life. Denmark is an amazing place. It's a magical place. It's as magical as Minecraft. Maybe even a little bit more magical than that. Okay?
Are these really the questions that I was called here to answer?
Yes. Sean, you are feeling lucky. You may win. You could win. So, how much code is behind that array ad shake? I don't know. This was written with Flash. So, stickers. Everybody loves stickers, right? All kinds of these ones that we'll be giving out here. The super C-sharp one. There it is. I'm going to put that back in the emote rotation here so everybody gets a chance to use that. I've been wanting to make that into a cheer mode so that you can cheer with C-sharp and throw C-sharp bits at my face. The old .NET bot. Right, and of course, the current emotes that we have. There's the GitHub Octocat with a rainbow beard. Clippy with a rainbow beard. And of course, the Fritz bot with the cool shades. All right, ready? Let's do this. Finished some stickers? Yeah. Tell you more about Snickers, says Michael Jolly. It's a chocolate bar that's made with nougat, caramel, peanuts, and it really satisfies you. It's amazing. Simon says, Flash, run away. I kind of agree with you on that one. But so it may. All right, let's do this. You love Snickers? I can't say that I would turn down a Snickers bar here. All right, let's do this. I gotta find the right slider for that. Holy crow, was that loud? All right, let's give out some stickers here. Nougat chocolate bar. Yeah. Nougat. And we're going to mail some Snickers. Darn it! We're going to mail some stickers to Fixter Jake. Congratulations, Fixter Jake. You still there, Jake? Let me know you're in the chat room. Yeah, there we go. Congratulations, Jake. I'm going to drop you a whisper. Let's see here. Fantastic. Every 100 followers, when we get to 7,300, we'll give out another sticker pack here. And thanks so much. I really appreciate all the support from everybody in chat. And of course, if we get to 8,000 before September 15th, I will dye my beard rainbow. For .NET Conf and TwitchCon, they're the same week. I will have that beard as a salute to you, our Twitch community, for both events. How cool is that? I'll be interviewing people like Scott Hunter, Scott Hanselman, other people named Scott, and even the D.D. Walsh. And I'll have a rainbow beard on this here face as a salute to you, and everybody will know that I support our Twitch community out there. Thanks so much. Bucharest again says nothing else matters. Yeah, there's one of the Scots. None of the Scots in the chat room. Terrific, Jake. Thanks so much for sending that information along so promptly. You're hyped? Time to add on to the C-sharp one you got from work. Oh, yeah. There you go.
Great Scott!
Page another Scott. There's plenty of Scots. Did you know there are 13 mentions of Great Scott throughout the Back to the Future movies? Ask me how I know. It's amazing. All right. Let's do this. Let's get back into this. No worries there, Jake. Not at all. Okay. How do I know? Oh, we went looking for it. And someone's edited together a supercut. There's 12 different end-thens. 6 of them are actually usable, and I've got all 6 of them loaded up for you, both on my Stream Deck and on the chat bot. So fire away the Scott commands, the end-then commands, and oh yeah, it'll run its mouth for you. Nope, didn't list the project, so let's put in a project here real quick. Jeff is, I know, learning about ML.NET and attempting to add a hat recognition feature to our chatbot. I think that'll be cool. That one was funny. Oh, yeah. Oh, they're all good. All right. Good, everything's fine. So let's continue here. So we're continuing through, we've added in, and we're walking through the ML.NET tutorial. So we added the model builder extension into Visual Studio here. And this is something that you want as an IDE to enhance and make your development experience a little bit easier, right? These types of things you're going to expect from an IDE. From a text editor, you want to just edit text. You don't want full-featured extensions that walk you through processes like this. You know what I mean? To generate your model, you need to select your machine learning scenario. Okay. Model Builder offers several templates: price prediction, sentiment analysis, custom scenario. Ooh, okay. So binary classification, predict positive or negative sentiment of comments. That sounds like something that our chatbot already does. And right, what that sentiment analysis number over there is. There's a sentiment command actually now in the chatbot, right? That should be working. Or not. I thought I deployed that. Didn't I deploy that? Maybe I didn't yet. Is it in there? There we go. The sentiment over the last minute was 77.1% active, positive, trending downward. No, it's trending up. Compared to the last 5 minutes, the most recent messages were positive. Yeah, there we go. There's all of our commands. So, I don't want that. I'm not predicting a... So we're not going into two categories. We're not predicting a numeric value. Custom models with data using classification, regression, and other tasks. That feels like where I'm going to want to be when I classify the... Or maybe it's this one, issue classification. Putting data into one of several different categories. Or maybe it's the custom when we get there for the hats. I don't know. Let's figure this out when we get there. I'm going to finish walking through the tutorial. We're going to predict sentiment based on the content of customer reviews. Okay. So we're going to choose the sentiment analysis scenario, all right? Which is a binary classification machine learning task. I don't know what that is. All right, continue. Download and add data. Download the Wikipedia detox data set and save it as this in the directory we created. All right. So it looks like I can right click and save link as. All right. cdev, and what did I call this again? What was it like? First MLNet. There it is. And I'll put it down in. Well, let's put it. Yeah, put it down in here, I guess. Right? I guess that makes sense. All right, so I saved it in there. Each row represents a different review left by a user on Wikipedia. Uh-oh. The first column represents the sentiment of the text. 0 is non-toxic. 1 is toxic. Yeah, they're saying things like,
I expect you to die.
That's pretty toxic. Right? But then again...
Boom goes the dynamite.
That's positive in how he said that, but it's definitely negative. I don't know. So this is the just do the clever thing in my app shrink wrapped ML in a box flavor of ML. I think so. Yeah. Right? Let's make machine learning easy for folks that want to do the simple scenarios. Right? If we can make that kind of thing easy for folks to use, yeah. Now it becomes impressive and easy for folks to do. This is kind of like where database access was 25 years ago. Right? People need to use database. How do we make it easier for folks to use database from their applications? And things like ODBC evolved and the other APIs that we now have that are common for databases. That's how I end all of my commit messages, says Michael Jolly. I wish you would die. No, I end all of my commit messages now with...
Well, do your best.
See? It's positive. It's welcoming. It's better than...
It's alive!
That's different, right? Okay. So each row, it's a comment, and then the sentiment. So it's things like this: 1010, whether it's toxic or non-toxic. Okay. Columns are separated by tabs. Data looks like the following. Blah 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 blah. Oh wow. Okay. Add data. In Model Builder, you can add data from a local file or connect to a SQL Server database. In this case, you will add the TSV from a file. All right, so file, select the file, and that's not where I want to be. Why did you go there? I mean, literally, that's... Whatever. You know what? Okay, there it is. Column to predict. All right, under column to predict, select sentiment. Hey, look at that sentiment. Label is what you're predicting. Okay, so we're predicting this value, which is, in this case, the sentiment found in the first column. The rest of the columns are features, which are attributes that help predict the label. Okay, so it's going to look at this feature, the sentiment text, and use that to help predict this value. Okay, got it. After adding your data, go to the train step. I think that's this. Here. All right, continue. You alternate between ending your messages, I wish you would die, and as the prophecy foretold. Oh, that's good. Okay. I like that. You could also answer your work ticket assignments with,
"You got the wrong guy. I'm the dude, man."
"I'm the dude. See? Wrong guy. Assign it to someone else." And when they finally do assign you the right thing, you can say,
"You're amazing. You figured this all out already."
And Hans Gruber. Hans Gruber's, pretty good. The model builder evaluates many models with varying settings to give you the best performing model. The default time to train, the amount of time you would like model builder to explore various models, is 10 seconds. For larger data sets, you should set a longer training time. Select Start Training to start the training process. I'm feeling lucky. Right? I'm going to go out on a limb here. I'm going to try something different. Give me 20 seconds on the clock. Go. Right? And we're waiting. I mean, does it really add that much more if we doubled the amount of time here? I mean, right? It doesn't say not to double the amount of time. I mean, let's see what happens here. Isn't the traditional ending, well, it works on my machine. That's a good point. I think you know what? I may have to reach out to the boss. And see if I can get him to record that as a sound as a voiceover for us. What is the maximum to train the model? I don't know. Let's see what this little eye thing is. Longer training time will give better accuracy. It's still letting me type these 9s. That's a lot of 9s I just put in the chat room. That's a lot of 9s. That's more than 10. That's like 25 9s. That's a lot of 9s.
Shame. Shame. Shame.
We may want to put a cap on that value. I'm not sure, but I'm just saying, okay? It might be the right idea because
you have no idea what you're dealing with.
I don't. I'm just using the text box. What about int64 max? Oh, we're bigger than int64 max there. No, wait. It's over 9,000. Oh, look, now I got a little red box on it. Oh, yeah, there's an error there. What do you think it might be? Anyways. That's better. It put a red box on it, but how long should I train for? What's that do? It opened a browser over here. There we go. Longer training periods allow AutoML to explore more models with multiple trainers and settings. So AutoML, I do know, is a command line tool that you can also use to build some of these models. So if you have more than a gig, 3+ hours. Yikes. Types of columns, text versus numeric. The type of machine learning task, regression versus classification. I have no idea what these things mean. I'm learning this. How do I understand my model performance? Model Builder by default splits the data you provide into train and test data. The train data, 80% split, is used to train your model, and the test data, the other 20%, is used to evaluate your model. So 4 out of 5 records are used to teach the model, and it uses the 5th record as validation to see if it worked properly. That's cool. Okay, that makes sense to me. Hey, Brave Cobra. Good to see you. Okay, so I did the training thing, and 70% accurate. That's pretty good, right? That's a C, right? In grade school, I would get a C if I got a 70. C minus, right? That's something. You can keep track of the progress by going in the progress section. No, it's done. Shows the accuracy of the best model that Model Builder has found so far. Higher accuracy means the model predicted more correctly on the test data. You think? Shows you which algorithm performed the best so far during Model Builder's exploration. Averaged perception binary. Okay. This shows the last algorithm that was explored. Oh. All right, so go to the evaluate step. Continue. Evaluate your model. After Model Builder selects the best model, it'll take you to the evaluate step. Ta-da. Which shows you various output, including how many models were explored and the ML task, in the case binary classification. All right. Let's see here. Make sure I did everything right here. Okay. So there's the models explored. Model Builder also displays top 5 models. There they are, including the AUC, AUPRC, and F1 score, which you can learn more about here. I'm not going to click through that right now because I don't know enough about it. Is that OX Valley? I see what you're trying to do there. That's hex. What there? This is ML.NET. We're learning a little bit about using the machine learning libraries that come with .NET Core now. These will run on Windows, Mac, and Linux, and you can use them to build and teach your applications how to make predictions based on a model that you train. And we're working through the intro to ML.NET that's right there on the ML.NET tutorial. I should have put that in the project command, shouldn't I? Let's put that on the project command. Where is it? The tutorial is at... There we go. Now it's on there. Neural networks? No, not quite. Not quite. So 15 models explored. Training time 10.57 seconds. No, I spent 20 seconds over here. I went a little further, but it only went through 5 models. I feel ripped off. Move on to the code step. All right, move on to the code step. Add machine learning model and projects for model consumption and training to your solution. All right. Select add projects. Well, it's not really a select. It's more of a click, but okay. Let's see. Model Builder adds both machine learning model and the projects for training and consuming the model to your solution. In the Solution Explorer, that's this dealio over here, you should see code files that were generated by Model Builder, including... Well, I named my project slightly differently. So I see Model Builder, and I see my model down here. Data models and a zip file that I guess has that, right, that trained model living inside of it. Kiorix, keep me honest here. Make sure I'm learning that. I'm pronouncing your name properly there. What I don't get is if you're using the same data preset of the tutorial, why the results aren't the same. Different processors runs different, right? Different speeds, faster. I don't know, or at least get closer results. Well, I went a little bit longer. This seems like building IKEA furniture, says Simon Jeering. Easy enough to open all the boxes and fit some bits together, but sooner or later you need to go back and read the manual. I agree, right? For the basic things like this, not bad. We can get something that fits our needs. But when we go and we try and expand this a little bit, and we want to get into this, training it to understand what my hats are, might be a little bit different. Let's see what we can learn here. If you increase the time to train, does it increase the number of models explored and hence the accuracy? I would think that. Paulo, I think that makes sense to me. So the console app is the .NET console app, which contains the Model Builder CS used to build, train the model, and Program CS, which is used to run the model. The ML.model is a .NET standard class library. .NET standard, of course, this runs on every environment, and it when it gets compiled, and when it's referenced and compiled, it'll be adopted so that it runs on the appropriate runtime that you're targeting with your application. So in this case, I'm targeting Windows console, so this will be compiled with the Windows console runtime information, so it runs on Windows console. I could also make this run on not just .NET Core, but on .NET Core on Windows. I can make it run .NET Core on Linux and have it run with the Linux runtime when I compile. Valley says, CSharp seems so confusing. Oh, or .NET as a whole, ratherly. So many different things. What are your concerns there? So, C# is designed to be able to do a whole bunch of different things as a language. You can apply different frameworks, apply and use it with different frameworks, whether it's building websites, building mobile applications with Xamarin, building IoT apps, working with machine learning models, working with database, with entity framework. So as a language and how you use it with the framework, and it's the same thing with Java and C++, depending on those different framework components that you choose, you're going to be able to compile and build for different things. You need different runtimes that are appropriate for those other operating systems. And .NET has the same thing, different runtimes that you can run your app on top of. Whether it's Windows, Mac, Linux with the .NET Core runtime, or the mobile devices with Xamarin. So things are going to get a lot simpler here in the next year when .NET 5 lands. And the promise of .NET 5 is, instead of having Xamarin and Mono and .NET Core runtimes, you'll just have one runtime, the .NET runtime, that runs everywhere. And it will adapt appropriately for whatever operating system you want to target and run on top of. Very much like C++ and Java, at some point you need to declare, oh, this is running on this thing, this piece of hardware. And because processors and operating systems are different, of course, we need to make sure that our code knows how to operate in those places. C++ is more like take a compiler, doesn't matter which, include the headers and link the lib, and now you can use a framework. Yes, you're including the headers and things that are appropriate for that operating system that you're targeting. You're binding to the runtime at that time that you're writing your code. With .NET, you're swapping in that runtime just before it runs. So this is a just-in-time compiler that's in effect versus an ahead-of-time compiler like C++. You compile all the way down so that it runs as native code. .NET, unless you're running in WebAssembly, you're running on a mobile device, doesn't compile to native code. It compiles to some intermediary language code that is then interpreted at runtime and delivered. Exactly. All right. Yep, pick your poison. So, hey, Pac-Man Jr., good to see you. So I've got these two new projects here, the console app now and the model. Try the model. You can run the console app to predict the sentiment of a single statement within the model. Okay. Consume your model. Okay, hang on. Wait a sec. To try the model, run the console app. Run the console app. All right, fine. Debug, start new instance. And it'll start the console app here for us. Here we go. Is it doing something? Here we go. Single prediction, actual value true, predicted value true. Okay. Yeah. I don't know what it did. All right. I don't know what that did. Model Builder has generated a trained model for you. Well, thank you. So now you can use the model in other .NET languages by using the following steps. From your ML app, from the app, reference the generated model. Okay. I'll do that. This is what that looks like. Yeah. In your app, add reference to the generated class library. Install the ML.NET NuGet package. Okay. Which is Microsoft.ml. It opened it in another browser over here. So let's do this. I'm going to come back over to first ML.NET. Manage NuGet packages. Right? These are all of those packages, right? Libraries, things that folks have written that we can reference and use. So there's Microsoft ML. I'm going to install this, the latest stable version, which is 1.3.1. They've been iterating on this every month, adding new features. So Problem with a lot of modern languages is that they're way too runtime dependent, both on a low and high level. Okay. At some point, you got to depend on a runtime. At some point, you got to depend on something that's interpreting and running your code. So, what are you going to depend on? So there's my reference. Okay. So right now, this is just doing hello world, but that's stupid. It wants me to just call consume model and to paste in a consume model method here. All right, don't mind if I do. Make that a var. Control dot on this, so I get my using statement. I want those to be vars. New model input. Maybe I'm missing it. Add reference to the model class. Yes, please. Make that a var also, because okay. So it's going to load the model in mlmodel.zip. Okay. All right. So it wants me to just call consume model from here. Okay. Consume model. There we go. And it'll run that. In your ML app, modify the sample text input.sentiment text in program CS. There we go. Well, that's silly. Why don't I do this? Right? String input text and right? Input text. And up here, I can just say, console dot read line. Come on now. Input text equals that, and I'll put that in here, and I don't need a console read line. It's already going to do that for me. So now it'll take whatever I key in and read it and force it through here. Let's see what that does. Right? Yep. F5. You can always write your own language if you're not satisfied with the current available ones. Yeah. CSharp is compiled, so it should not have to rely so heavily on the runtime. Well, so in right, the just-in-time compiled languages, all the .NET languages are like that, and because that's the heritage of .NET, and Java is like that also. You compile, you get just-in-time code. In .NET, we call it intermediary language, and at runtime, it will compile that for the appropriate runtime that you're on. Now, Xamarin and Mono allow you to further AOT ahead of time compile all the way down to a target runtime, so that you're not specifically, because you're going to target a specific machine, a mobile device, or a WebAssembly at this point. So let me key in something here. This is wonderful. And now it's going to do the analysis on that, and that's not right. That's really not right. I feel like it's wrong. .NET Core 3 adds the ability to do package applications and its runtime inside a single exe. Yes, it does. I need to update my hat to account for the new Visual Studio logo. No, that's the Visual Studio 2019 logo. I like cheese. Let's see what it says. Toxic. Are you kidding? That doesn't make sense at all. You know what I mean? Let's just take a...
Great Scott!
I know! Right? Love butterflies and unicorns are my favorite things. Okay. Right? The input text that's passing along are that. Okay. Well, are those things. Yeah. Right? So I'll unclick that. F5. Not toxic. Finally. Oy, oy, oy. If you look at the trend of what's going on, we're heading towards a further abstraction of language and platform with WebAssembly, meaning the browser is fast becoming the new operating system. Yes. Oh yeah, interpreted languages, further interpreted languages like Python, JavaScript, make it a little bit further out that we're pushing away from the virtual machine and how we're compiling and running. Playing with machine learning, yes we are, Frank. So, all right, so it's working. It's not necessarily always right, but it's working, right? I mean, I could break this up, this consume model, so that so that the engine is loaded and we run it through the prediction here, right? I mean, right? So I ran that. Next steps. There's other data sets to work on. All right. So I guess we know where. So let's run something here called, let's call it setup model. Let's see if we can make this a little bit easier to work with. Right, I'm gonna move this part later. Actually, I should leave that there and move the other stuff, right? Public static void setup model, right? I forgot the L on setup model. How could I? All right, so there's my context, the model, loading that up. The prediction engine is going to come off of that. Okay, and I need that down here. So let's make this. Right, that's going to create a prediction engine of model input, model output. Okay, sure. If I control dot on this, yep, generate that field. There it is. Good. So now that works, and I should be able to just do it now, right? Let's move this up here. So now we're going to console read line and consume text. So let's do this. Say while not, let's say var red text. While not red text equals ZZ. Do that. Right. Yeah, that should work. No, not silly. Okay, so now it should read the text and then push it into the consume model. Let's see how that works. Alternative corn. Hello, hello. You heard about ML.NET. Is it any good? We're trying it out here. Let's see what happens. So it's running sentiment analysis off of some toxic, non-toxic indicators from Wikipedia. So I wrote earlier, I like cheese, and it was telling me that's toxic. I hate cheese, toxic. Cheese is my best friend. Okay, not toxic. Okay. Cheese is not my friend. Now I'm worrying. I hate cheese. Oh, good. Cheese is toxic. Cheese is toxic. Right? I mean, we love unicorns. Okay, good. So whatever's generating that model assembly, was it doing that locally on your box or in the cloud, or only your app is running locally? My app is only running locally. This is all local. There's nothing reaching out to the cloud. It's running with a small data set here. When you look at right? The data set that we downloaded here, it only downloaded 250 comments. So it's not a huge data set that we're training with, right? We would want to train with a heck of a lot more data to get much more accurate analysis of all the statements that we could be keying in here. Depends on the kind of cheese, says Brave Cobra. Yeah, there's definitely some more toxic cheese than others. Okay. Now you see how machine learning can stink sometimes. Yes, I kind of agree with you. Brave Cobra says, that's a cheesy model to me. Yeah, it's okay. I do think it's cool, right? To have a machine kind of make a prediction based off of what it's been trained with, that is pretty cool. Now, the next thing that we wanted to figure out is there a way that we can train the engine what my different hats are? Each one of my hats is a different set of colors, has a different logo on it. Can we isolate images of those and have it predict? I mean, I'm always in the same location here on stream, but can we have it predict identify which hat it is that I'm wearing based on a trained set of images of all the different hats that I've worn here on stream? Maybe. That's what we want to figure out. That's what we want to try and learn here together. So I'm going to go back over here to this. Gamer2313 asks, any good resources for getting into C# for someone with Java knowledge? There's out here on .net.microsoft.com. You can click through to learn, and there's a whole bunch of getting started bits here. Depending on how you want to get involved here, you can click through and learn the basics with getting started with .NET, getting started with C#. There's a great group of folks here on Twitch that are walking through and answering questions and doing samples here. If you're familiar with Java, you already know a lot of the structure for this. Java and C# look very, very similar. It's just a question of learning the base class library, the BCL, all those things that come with .NET that you can reference. So, C# Corner is a great location. Absolutely alternative corn. C# Corner is a great location to get started learning more about it. They have a tremendous repository of articles over there, features that you can learn from. Right, CSharpCorner.com. There you go. So you can absolutely check out that website. Great articles from all kinds of folks that are MVPs, that are specialists. Some Microsoft folks show up here from time to time writing articles telling you how to make the most of the technology. So it's not exactly a training website, but it's more of a blog and a recipes website, right? I need a little bit of code that does this. There's great articles there that'll show you how to do those things. So I think I want to do model builder guide. I think I want to figure out how to make a more robust model here that'll learn about images that we're going to train it with, right? Model Builder is a simple UI tool that runs locally for developers. There you go, to the question earlier. This is running on my machine. Runs locally to build, train, and ship custom machine learning models in your applications. Try it now. Do it. Try it now.
First, take a big step back.
Okay. Take a big step back, and you can learn more about this. That was my producer, Len Grossman. Installation, scenario, data, train, evaluate, improve. That other one needs some improving. Things you can try to improve your model performance. Train for a longer period of time. This will provide automated machine learning to try out more trainers and find a better model for your machine learning scenario. Sometimes the amount of data or quality of data is not sufficient. I think that's what we saw with that sample. We only had 250 records. If we had 2,500 records, now we're talking. Now we've got a little bit to work with. Try adding more data for Model Builder to operate on in case of classification tasks. You can make sure that there is a good amount of data available per classification category. thank you for the follows. Let me see. Hack the Planet TV. I think I know who that is. Thanks so much for the follow. LJ Palmer, thank you for the follow earlier. Oh my gosh. MCD Indio, welcome. Thank you for the follow. And I'm not sure how to pronounce this last one. Thank you for the follow as well. Appreciate all of our new followers joining us here today. So this is the first preview. It has some limitations. We're working on improving the experience. We currently support TSV, CSV, and SQL as the data types. Alternative Corn, thanks so much for the cheer. We'll log that. How to make it learn from images, that is the next step. But thank you, Alternative Corn. We'll make a donation to Coder Dojo, who we're supporting all quarter long for all of our cheers and subs. Really appreciate that. So the file should have a header row. So this is only supporting text is what this is looking like here. In which case we're going to need to build a model somewhere else. We're not going to be able to use this to build a model. Rats. Because we're using a binary data type, right? An image. It's not a TSV, CSV, or SQL. The plot thickens. So how do we train ML.NET if we don't have a text data set, right? If we're doing image analysis, right? Is that something we can do? Right, samples, sentiment analysis, spam detection. This was something that I thought they demoed a while ago. Flowers classification, iris flowers classification, that might be, right? Movie recommender, price predictions, demand, clustering, flower, I don't know what clustering means. Anomaly detection, that's cool, anomalies, okay. Image classification, that feels like where I need to be, right? Computer vision, right? This is the kind of thing. Yeah, it's like, it is very much a cognitive service, but I mean, I could do that with Azure Cognitive Services, I think, but I'd rather have it all run local to the bot. I think that makes sense. Let's see what this is. Image classification. You're kidding. It's a link to the image? Come on. Very funny. Okay, I don't know what the difference between these two things are. Samples, end-to-end apps, deep learning image classification. This is samples, CSharp, deep learning image classification. They're the same. Okay, let's see what this is. Image classification, scoring sample. Image classification is a common case in many business scenarios. For those cases, well, I hope it's a case in my scenario. For these cases, you can either use pre-trained models or train your own model to classify images specific to your custom domain. That's what I want to do. I want to train my own model. Alternative Corn says, I've always been impressed with the great examples and documentation Microsoft offers. Yeah, I think that's definitely something to be said there. When you have a great set of documentation and examples, it really enables folks to get started faster and better. Your internship ends on Thursday, getting ready to graduate now that you've gotten a taste of the real world, says Fixter Jake. More power to you. Good luck to you, Jake. All of the ML.NET tutorials I could find for image classification start with a pre-trained TensorFlow or Onyx model. Not sure if there's a way to train a model on image data using just ML.NET. We'll find out. One is supposed to be a console, the other is a form application. Is it? Right, this is machine learning samples, blob master sample, C#, getting started, deep learning image classification, TensorFlow. End-to-end apps, not just getting started. All right, well, we're getting started. Okay, there are two data sources, the TSV file and the image files. The TSV files contains two columns. The first one is the image path. and the second one is the label corresponding to the image. Aha. So if we have images of that, right, that are trimmed that are the same size of my hats, then we can generate, right, here's a list of the images, right, and maybe it's the Visual Studio 2019 hat.jpg and it says Visual Studio next to it, Visual Studio 2019 as the label. As you can observe, the file does not have a header row and looks like this. Okay. The training and testing images are located in the assets folders. These images belong to Wikimedia Commons. Pre-trained model. There are multiple models which are pre-trained for classifying images. In this case, we'll use a model based on an inception topology and trained with images from image.net. This model can be downloaded from... Okay. Sure. How do we train our own model? That was the question. How many hats have you to photograph and have a usable sample data set? Well, I have, right, I've got 40, 50 different hats, but I think the question is going to be getting different pictures of those hats so that they're in different lighting, different image sizes, so we can say these are all that hat, right? Not just one image that says, oh, that's the Visual Studio hat. We want to have like 10 different images that are different sizes, different lighting. So we say, that's this hat. That's what this one is. So there's an explanation about the two types at the beginning of the README. Just go to the beginning of the README. Okay. Getting started, ML.NET code focus samples and end-to-end apps. End user sample web and desktop apps infused with machine learnings. Ah. Well, that explains it a little bit better. Okay. Thank you. Thanks for looking that up. Kiorix? I hope that I have that right. Big thanks to you. Where's my games? There it is. There we go. Points to Kiorix. There we go. See that? Give out coins here. All right. And I want to go here. Gotta find all my buttons here. Has anyone used ML.NET for audio analysis yet? That's a great question too, Deathpacks. Really, it's another binary file here, and I know during build last year, build 2018, there were some samples where they analyzed music and MIDI files. We had some of the folks from the ML.NET team on the show, and they were working through that. So they're using this model. Okay. Trained with images from image.net. Well, I want to train it with my own images, but hey, whatever. Okay. Note that this sample only consumes a pre-trained TensorFlow model with ML.NET API. Therefore, it does not train any ML.NET model. TensorFlow is only supported in ML.NET for scoring, predicting with existing TensorFlow trained models. Okay. You need to follow the next steps in order to execute the classification test. Set the Visual Studio default startup project to this project as starting in Visual Studio. Hit F5 in Visual Studio, you think? The output will be similar to this screenshot. Reading the model. Okay. Classifying the images. There is a single project in the solution named imageclassification.score, which is responsible for loading the model in TensorFlow format and classifying images. Model scoring. So here's how it's right. Image path and label. That's the format of that TSV, right? This thing that it's loading from. Okay, I got it. So we've got a column, that's the images, a column, that's the labels that we're going to apply. And it's got a static method here to read from that CSV file and put it, it's not a CSV, it's a TSV. That's a wrong name there. Load the data using text loader, read from, yeah. The image file used to load images has two columns. First one is the image path, second one is the label. It's important to highlight the label in the ImageNet data class is not really used when scoring with the TensorFlow model. No, it's a label that we're going to use to reference. It looks like this thing. Give it this label. It's used when testing the prediction, so you can compare the actual label of each sample data with the predicted label. Yeah. As you can observe, the file does not have a header. Right, you mentioned that earlier, okay? I get it. The inception model has several different parameters you need to pass in. Image height, image width, mean. Channels last. Okay. Can you detect on the fly from video? So Brave Cobra, I don't think we're going to be able to detect on the fly from video. However, Twitch takes a screenshot and uses that screenshot for the card for the channel while we're broadcasting. So either that screenshot, or maybe we can open a headless browser, go to Twitch and take a screenshot. Maybe we can do something like that to get this. There's got to be a way to get that screenshot automatically. Drexel Dave says, I feel like ML.NET is sort of dangerous. I've seen people training models that really don't make logical sense. Interesting. Mathematically, you can create models that predict data accurately, but don't really mean anything. Interesting. Yes, headless browser. If you look at Phantom, right, the Phantom, I believe it's called Phantom JS browser. Do I have that right? There it is. Scripted headless browser. You can actually run this inside of a Docker container. I said Docker container. Robert Tables usually appears, but I know he's busy moderating another very busy channel right now. Suspended until further notice. Oh no, what happened? But you can point to a website and tell it render this page out to an image. Exit the file. Archiving the project, suspending development. Oh no, due to lack of contribution. Oh no. Oh, that's a shame. It's a really great project, Phantom JS. It looks like it's still available out there, but more power to the... Ooh, look at that guy. Puppeteer is the way to go, you think? I'm not familiar with Puppeteer. Puppeteer. No. Headless Chrome Node API. Really? What do we got here? And it's at pptr dev. Okay. Usage. Require. Example, go to, take a screenshot, close. Fantastic. That's easy. Then we can get an easy screenshot and we'll be able to zoom in on just the video. Right? That's not bad. Curix, I think you're onto something here. To get the screenshot. Alternative Corn, always ask questions. Never have to announce you're asking a question. Please, always welcome to ask questions here in the channel. That goes for everybody. You'll need a trained model of my various hats from TensorFlow. Yes, Musical Bookworm, I completely agree. And we have a link or other TensorFlow tutorials as a starting point for image classification. Let's see what we have here. So this is Musical Bookworm is pointing us to here. Train your first neural network. La-dee-da. All right, what do we got? This guide trains a neural network model to classify images of clothing. Hey! Great example, Musical Bookworm.
Squirrel.
No, we're on track here. I think we're okay on this one. Let's see here. This is a fast-paced overview of a complete TensorFlow program with the details explained as we go. Good. This guide uses tf.keras, a high-level API to build and train models in TensorFlow. Okay. So this very much looks like Python we're going to be using here to build this. Am I right? Import the fashion MNIST dataset. This guide uses the fashion MNIST dataset, which contains 70,000 grayscale images in 10 categories. The images show individual articles of clothing at low resolution, 28 by 28, as seen here. Oh man, look at all that. Right? Can I zoom in? No, I can't zoom in. View image. Right? Holy crow, look at all that stuff. All right. Makes sense. Cool. Do I know of any .NET Core compatible drawing libraries that will work with Linux? .NET draw. What do you mean by drawing libraries? You're trying to render an image? There are a couple of them out there that folks are using. Right? That are not right. That are not just on Windows. If you're doing image processing, right? Core compat system drawing. I don't think you want that. But it's the mono implementation of system drawing. Yeah. There's appropriate runtimes to use. ImageSharp is one that a lot of folks use. There you go. Cross-platform library for processing of image files. So, right. Oh, Brave Cobra. I'm not going to read that. That's not right. No. No, no, no. Just a total coincidence. You've just been using Puppeteer. Sometimes found it really straightforward. Yeah. Oh my gosh. Okay, so Fashion MNIST is intended or as a drop-in replacement for the classic MNIST. Is that how you pronounce that? Dataset often used as the hello world of machine learning programs for computer vision. Contains images of handwritten digits. Yes, I've seen that. In an identical format to the articles of clothing we'll use here. Okay. We'll use 60,000 images to train the network and 10,000 images to evaluate how accurately the network learned to classify images. Okay. You access the Fashion MNIST directly from TensorFlow. Just import and load the data. Yes. Yes. Okay. So it's already available for you. And you just say load data. Okay. Loading the dataset returns 4 NumPy arrays. Train images and train labels arrays are the training set the data the model uses to learn. The model is tested against the test set, test images, and the test labels arrays. The images are 28 by 28 NumPy arrays with the pixel values ranging between 0 and 255 because it's black and white. The labels are an array of integers ranging from 0 to 9. So we may have to cast these images to black and white. Gareth asks, how am I planning to get enough images to train a model for my hats? I only need 70,000 images of hats to train it. How's it going, Gareth? Good to see you. That's Gareth. It's great to see him because everything's awesome. Make sure you check out Gareth's stream. You can find him streaming as a member of the Live Coders team. Click that Live Coders link just below me over there, and you can learn about all 65 members of the Live Coders that are writing code live here and teaching, working through software projects like this, and other interesting things that they're working on as well. Would you need network access this way? No, I would not need network access, Brave Cobra. If I'm training all this stuff locally, and I have my model all trained and saved, I wouldn't need to hit the network. I could run directly against a local instance of this. ImageSharp is exactly what Alternative Corn was looking for. Congratulations. That's great to hear, Alternative Corn. I'm glad that's going to work for you. Oh, I have all that sound bites, Gareth. I have all of them.
What's that?
I have sound bites.
What's that?
No, a lot of sound bites. And now you know.
Knowing is half the battle.
Knowing is half the battle. Duke of Twitch. Duke Twitch, or is that Duke of Twitch? Welcome, Duke Twitch. Great to see you. Thanks for joining us here. So, thinking out loud here. If we were to build and train using a very similar data set here, we'd have to use black and white images of hats. 28 by 28 is really small. 28 by 28 pixel? Where'd it go? Right there. So, Brave Cobra, what I understand from just the little bit of reading that I've done over here, the model is data that's been configured, that's been loaded and analyzed, that knows how to take some example that's been given in the in this case the first example, the first column of the model, analyze it, and apply a label that's on the second part of the model. And we're going to apply different algorithms to figure out how to correlate those things. You then use the results of that model, that piece of code that's sitting on disk, to run your predictions through, to run your, right? So it's done all of its predictions and it's figured out how to make a good comparison between the two. We're going to run through some new test data and say, well, using that model that you've analyzed and built some correlation between, run this new piece of data through it and tell me what you think it is based on those other factors in the model. That's what I understand a machine learning model to be. Simon says, surely you only need a bunch of images freeze frame from your Twitch streamers of each of the hats from different angles as the input. Simon? Exactly. And guess who has 277 videos sitting out there on YouTube begging to be analyzed? Huh? What do you think of that? So, my thinking is, when it comes time to build the model, we can right, have it navigate to those different videos, right? We know where the hat is in the model. We can, right, because I'm always sitting in the same spot. We can have it grab that area of the video, take a screenshot, and right, turn that into black and white, and then we need to go through and assign what the name is of that hat to 70,000 records. Maybe? Okay, for the same videos, we're going to be able to copy and paste and at least repeat across those. Kind of like the old sounds like method, but more complex, says Brave Cobra. I think so. Simon jeering. Yeah, to misquote Short Circuit, more input. And hopefully we get it trained enough that it'll go really fast. It'll go so fast.
They've gone to plaid.
They'll go to plaid. Janescu is saying Onyx AI, perhaps. I'm not familiar with Onyx. I would need to learn a little bit more about that. Onyx is supported by ML.NET. Duke Twitch says, I'm watching a workshop that I did of ASP.NET Core. Hey, thanks so much for tuning in. There's 2 workshops out there on YouTube. There's one that goes to 2.1, and there's a new one that we just recorded about a month ago that targets ASP.NET 2.2. They're both great. They're both about the same length, 6 to 8 hours. Check them out. Let me know what you think of them. Yeah, we're really excited about those. We're looking at doing some more workshops in the future. I've got tons of content that we're going to be building around and recording these longer form. Oh my goodness!
CS Kittens just resubscribed for 9 months. We've had a Twitch baby.
Oh my god!
Name it JavaScript tense.
Talarganza, thanks so much for the follow. I appreciate you joining us. Fierce Kittens is here. Welcome. That's my good friend Fierce Kittens. She's a creative streamer. She does once or twice a month. She writes code live on her channel, and I think we might set up to raid her a little bit later. She loves JavaScript. Right? You see? No, she doesn't like JavaScript. She'll freak out with JavaScript. She's a good friend of the channel. We've done a pair programming stream with her in the past. She's tremendous. Besides doing code here on Twitch, she also does some other creative things, some other art, some other crafts. She's done painting, making handbags, amazing. She's working on cosplay sometimes. Really great stuff. You got to check out Fierce Kitten's stream. Can somebody throw a shout out to Fierce Kittens out there for me? But 9 months, yes, the Twitch baby meme, and just because we know Fierce Kittens loves JavaScript so much, to name the baby JavaScriptins, that's a thing. You might be late though. Oh well, we'll see if we can catch you, if we can raid right into you. New glasses also. Duke Twitch says it's great. Well, I'm glad you enjoyed the workshop there, Duke Twitch. We're around here 4 or 5 times a week on this stream. Males Hussein. Okay. Thanks for the great content. Just rush home. Do not want to miss this. Well, gosh, thank you. You never have to rush. There's always video on demand here on Twitch, and we archive things over to YouTube. Lots of shout outs for Fierce Kittens. Thank you so much. No, not javascript.net. Oh no, you missed the stream. Did it go over there? Did I miss it?
What's that?
You missed the stream. It's
Wait, Master. It might be dangerous.
It might be, but I mean, just for missing the stream, I've got to say,
Shame. Shame. Shame.
Fierce Kitten says every time people mention JavaScript, a demon gets its horns. What are you thinking? No, that's wrong. That is so wrong. A horse, on the other hand, chimes in because horses love JavaScript. Love it. I don't know who likes XAML. We'll figure out who likes XAML. So, we are going to be wrapping up here in just a few minutes. Just checking in with the family over here. Cool. Let me see what's going on. Okay. Let's see here. All right. Let's see what we can do here. So, going back to the TensorFlow example. So, I think we're going to have to get a whole bunch of images, and we can probably get those from my YouTube videos. Explore the data. Explore the format of the data set before training the model. Following shows there are 60,000 images in the training set. See, it's not 70,000. It's 60,000. All right. Let's see here. Let's see. Divulger says, is looking for some help getting started with Azure. There are some startup programs for Azure that you can look into. Take a look at the website. There's ways to get startup credits for Azure for small companies that are starting up, and you can get a lot of credits as a startup there. I'm not going to dig into that right now, but drop me a message on Twitter and I'll see what I can do to hook you up with some links. Every language has its uses, says Fierce Kittens. Yes, the requirements of your users drive the language choices. Yeah, agreed. You've been developing a Discord bot in .NET, says Alternative Corn, for a while. Absolutely no experience with VPS hosting. Will VPS hosting allow running .NET Core applications? VPS. Virtual private servers? Well, you can run .NET Core inside of a Docker container. So put it inside of a container and you can run the container on those, I believe, and you'll be good to go. But .NET Core applications, you can compile with the runtime and deploy the whole enchilada and you should be good. So, yeah, take a look at that. All right. So it looks like we're going to need to, each data must be pre-processed before training the network. If you inspect the first image, you will see that the pixel values fall in the range of 0 to 255. Okay. Now, why isn't that black and white? Why'd they make it a... We scale these values to a range of 0 to 1 before feeding the neural network model. For this, we divide the values by 255. It's important that the training set and the testing set are pre-processed in the same way. Yeah, okay. Display the first 25 images of the training set and display the class name below each image. Verify that the data is in the correct format, and we're ready to build and train the network. So, ankle boot, yeah, okay. T-shirt, t-shirt top, dress, t-shirt top, sandal, okay. So, the different articles of clothing, that makes sense. Building the neural network requires configuring the layers of the model, then compiling the model. Okay. The basic building block of a neural network is the layer. Layers extract representations from the data fed into them, and hopefully, these representations are more meaningful for the problem at hand. Most of deep learning consists of chaining together simple layers. Most layers, like TF, Keras, layers, dense, have parameters that are learned during training. Okay. The first layer in this network, flatten, transforms the format of images from a 2D array of 28 by 28 pixels to a 1D array of 28 by 28 or 784 pixels. Sure, that makes sense. Okay. Think of this layer as unstacking rows of pixels in the image and lining them up. Right, so you get just a string of them instead of a square. Okay, I can follow that. Startupsmicrosoft.com. There you go. That's another good location for folks to go. You can do color and TensorFlow as well, just a bit more complicated to process the images. Musical Bookworm says, they're a TensorFlow beginner. Cool. Still working through tutorials, but I've already done this one. Oh, fantastic. Before the model is ready for training, it needs a few more settings. These are added during the model's compile step. Loss function, optimizer, and metrics. This measures how accurate the model is during training. Cool. We want to minimize the function to steer the model in the right direction. Yeah, that makes sense. This is how the model is updated based on the data it sees and its loss function. Okay. Metrics used to monitor the training and testing steps. Okay, I understand that. The following example uses accuracy, the fraction of the images that are correctly classified. Sure. Train the model. Training the neural network model requires the following steps. Feed the training model to the data. The train images and train labels arrays. Sure. The model learns to associate images and labels. Okay. We ask the model to make predictions about a test set. In this example, the test images array. We verified that the predictions match the labels from the test labels array. Cool. To start training, call the model.fit method. The model is fit to the training data. All right, so let me think this through here. Fierce Kittens is now hosting us. Well, thank you so much there, friend. I really appreciate you hosting us.
You have to ask me nicely.
And I'm more than happy to be here on the Fierce Kittens channel live. Look at me, I'm talking about JavaScript. Actually, I'm talking about Python. That's okay. We like Python.
What'd you do?
I'm learning about Python and training models here. So, thinking out loud. Tell me if I'm not oversimplifying this. I feel like you'd lose relationships between the vertical pixels when you flatten them out like that. I kind of agree with you, Zamalama. Wonder how training two models against the transpose and comparing the outcomes would go. Maybe. What if it's taking the data and it's flattening them out, right? Each one of these images, right? And it's got numbers 0 to 255 for how bright each one of the images, each one of the pixels is. For all 28 by 28 of this. And it turns it into just a 700 byte long array, 784 byte long array. Couldn't we just put that in a SQL Server database? And right? Where am I here? Right, and just do this same thing, training the doodad because it's just got a byte array. Oh, don't get me started about the snakes thing. I kind of agree with you, Fierce Kittens. We're going to need higher res pics to do training, right? 28 pixels by 28 pixels. These are really small here, right? I feel like we're going to need at least 100 by 100, if not 200 by 200 to get a good picture. And I feel like we're going to want we're not going to want a single byte. But I feel like we're going to want 3 bytes so we can set the RGB of whatever that pixel is, which is going to make the image significantly bigger. If we're 200 by 200, right, each one of those images then is 200 by 200 is, what, 4 and 4 zeros? 40,000. And if we put 3 digits with each one of those, it's 120,000. 120,000 bytes. Maybe? And use that to train. Maybe? Wouldn't I need images of hats only? Well, Brave Cobra, I want not necessarily of hats only, but hats as they're on my head, because that's what we're going to be, that's what we will eventually test against, because we'll take a screenshot of where I am, where my noggin is here, isolate that part of the video because I never move, and grab the image, grab the hat image, and test against that. Store them in Azure Blob Storage. That's not a bad place to store them, but we need to turn them into raw data so we can analyze it. Yeah, Simon's right. More input. Surely it's more accurate in color, given that it's a differentiating factor in logo design. I kind of agree with you, Simon. We're going to need to look at that. Numbers escalating exponentially on the time it'll take to train it. I kind of agree with you. And if we set up, right, if we set that up to run training over an hour or so offline, let it do its thing, we might get a nice model out of that we can use. I mean, this is a very simple making, and then, I said it, make predictions, model predict test images. A prediction is an array of 10 numbers. These describe the confidence of the model that the images corresponds to. Each of the 10 different articles of clothing. Oh, okay, so this is each one of the 10 and how close it is. Well, this one it's pretty close to, and that one it's really close to.
And then?
Right. Yeah. The max is the 9th one. Right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one. That's in at 80%. Yeah. We can check the test label to see this is correct. Test label 0, 9. We can graph this to look at the full set of 10 class predictions. Look at that. All right. And that it's 80% accurate. Cool. Okay. Plot several images with their predictions. Okay. Correct color correct predictions in blue, incorrect in red. Okay. So in that 1, 2, 3 by 1, 2, 3, 4, 5, in these 15, it got 14 of those predictions correct. That's not bad. Doesn't the Azure Custom Vision Service do all this work for us? A bit. It doesn't know necessarily all the things that we do, and
Moist Booty Boy just resubscribed for 2 months. 2 months.
Thanks so much for the resub. I appreciate that, and we'll make a donation to Coder Dojo, like we are with all of our subs, all of our cheers here, all quarter long. Thanks so much for that. But yes, you're right. Azure Custom Vision does do that, but I need to be connected and using Azure and using... it's actually quite expensive to do those tests, to run it. So only if you have... I mean, this is a toy that we're building here, right? This is something that's helping us learn a little bit about machine learning, where that's machine learning as a service. Go load all these images up there, identify the things, and spit out an answer. So, yeah. Right? That's a thing. But I want to get a little bit more hands-on with what's involved in building a model, what's involved in training the model, and then applying it. So, let's see here. Is there a way to debug SQL code executed by the web server inside Visual Studio? Yes. Well, you want to get all the way to the SQL code, to the SQL code? You want to just see the SQL code that you want? Let me know, Duke Twitch. Either way, you can actually run, when you hit the debugger in Visual Studio, it'll step through and take you to those objects. We're using an object relational mapper in those samples that you're seeing, and we're hiding that SQL. You can get the SQL out of Entity Framework. You can extract that. You can log that if you'd like, so you can see what it's actually executing. Yes, those emojis did go across the overlay. Yes, they did. Pac-Man Jr. says, custom vision you could run on-prem in a Docker container once you train them on Azure. There's a thing that it calls back to Azure and it logs how much you use it, I believe. But you can export models from custom vision. Nice. You found cognitive services to be too expensive if you have a lot of data. This would solve it, but you need to make it yourself. Exactly. I want to try and learn something new here. Get outside the box. Something custom. Yes, the emotes show up. Of course they show up.
Put the candle back.
I didn't see those emotes. That's too many emotes. Try it again. SQL trace could help? Yeah, they could. Yep. I'm waiting to see those emotes go flying by. They should go flying by. Right? It's amazing. All the emotes. There they go. Grilled cheeses. It only sends, I think, the first 8. So I didn't want to flood my screen. There we go. There's some more. Right, and only subscribers get that opportunity to do that. Plural, Stelzy, tacos. Yep, you can play that game too. There's the tacos. Everybody loves tacos. See that? And that helps with the sentiment analysis over there. So, and then we need to build a model, it sounds like, in order to work with this. We need to build a really big model so we can load this up. All right. What's this? Images. Transfer learning with... what? I have no idea what this is. TensorFlow Hub is a way to share pre-trained model components. Yeah. In ImageNet class. Yeah, this is the one that it was mentioning over in the ML.NET sample. I can't imagine this is going to know. Well, there's Grace Hopper. Okay. What's pix to pix? Neural style transfer, image segmentation. What's this? Well, that doesn't help. Learn how to segment images. Segmentation is the process of generating pixel-wise segmentations, giving the class of the object visible at each pixel. We could be identifying the location and boundaries of people within an image or identifying cell nuclei from an image. Huh. All right. Large number of car images, each car taken from a different angle. In addition to each car image, we have an associated manually cutout mask. Our task is to automatically create these cutout masks for unseen data. Ooh. Oh boy. Fierce Kitten says, Fritz, please stop interrupting taco talk.
Wait, let me explain something to you.
This is my channel, Missy. And you're in my chat room. Okay? It's Tuesday. Please observe its glorious taco-ness. All right. So what I'm seeing here is we're going to need to... Well, I don't want to do this bit here. We're going to need to get a little bit out there and figure out how to set up and build our model. We're going to need to capture a lot of images of Fritz hats. Lots of images. Fortunately, right, we've got lots of images. We've got all that video that we can mine. So it sounds like we've got a couple steps here that we need to do. We need to do a little bit of research to figure out how we're going to generate our model. What's the process here to actually generate that TensorFlow model that we're going to be able to feed into ML.NET and have it start to do the identification with? Clearly, once we have the model, right? Here with ML.NET, this feels like it's as simple as, where is it? New model input, send in whatever that model input is. And in our new case, it'll be an image of my hat. Predict a result and then output that, right? This part seems simple. It's getting that thing that's going to be a little bit of a challenge. So I think we're going to need to spend a little bit of time figuring that out. Yeah. I need to wrap up though. I've got something going on here with the family that came up that I'm going to need to take a look at. Taco model input. Yeah, we could probably do that, but I'm not analyzing tacos here. I'm doing something simple. I'm analyzing hats to figure out the logo and the color and be able to guess, oh, that's the Visual Studio 2019 hat. But we're going to come back to this another time after we do a little bit more research and we figure out a strategy and we get the some images, and we'll do something to capture images from our videos. We'll have to set up some sort of a script that'll analyze those videos and pull out that content. You know what I'm going to do here? Let me see. I think we've got somebody that we can raid here. Let me see if we can do this real quick. Oh yeah. He's not even going to know it's coming. Let's set up a raid. Let's put out the raid call, and I need to fix the structure of this. Grab that first line of text if you're a subscriber in the chat room. If you're not, that's okay. Grab the second line of text out of there, and we're going to announce our presence. We're going to visit our friend Blue Lava. This is another one of our friends from Twitch. This is John Bulava. He's working on, he calls it Restful Doom over here he's working on. And we are going to head over there. He's writing some code, and I'm not quite sure what it is that he's doing here. My Twitch UI is frozen. There we go. Thanks so much, everybody, for joining us. We're going to do a little bit more research on this, see if we can collect some of those images of my hats so that we can start modeling and loading up a model for this. And maybe we'll come back to this in a week or so when we've got all that data collected and we can start processing. Thanks very much for joining me, for walking through and learning a little bit of ML.NET with me. Get ready to say hi to Blue Lava with me. I'm going to copy out that raid statement so we can head over and say hello. All right, friends. Thanks so much for joining us. I will be back tomorrow. 10 a.m. Eastern is when I'll be back. And I hope you join me on Thursday. Thursday at 10 a.m., I'm going to have a guest. My guest will be Jeffrey Palermo. We're going to be talking about Azure DevOps, building your application, automating all kinds of DevOps things around your applications so you can get the best bang for your byte that you write. See that? I just made that up. Alrighty, friends. I will see you next time. Take care.